Tell me the duck story.
Bum, 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 ba-dum, ba-dum. A duck walked up to a lemonade stand and he said to the man running the stand, "Hey, bum, 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 got any grapes?" The man said, "No, we just sell lemonade, but it's cold and it's fresh and it's all homemade. Can I get you a glass?" The duck said, "I'll pass."
And welcome back. Today we're going to look at chapter 6.5. This is on percent of change. So let's go ahead and dive right into this. The percent of change is the percent that a quality changes from the original amount. Whether it's going up, whether it's going down, it's how much it changes, and we're looking at it in the percent form. The basic formula we're going to use is the amount of change divided by the original amount. So we'll look at two different ways this can work. So we have what's called a percent of increase and a percent of decrease. So with the percent of increase, you're going to, it's when your original amount increases. So what you do is you will take the new amount. So let's just say, for example, you start off with $45 and it goes to $65. So it's increased. What we would do is we would write in our little formula here is we would put the new amount, which is 65, minus the original amount, which is 45, and we divide it by the original amount, 45. And then we just go ahead and solve this problem, and we would find out a decimal, and we change it to a percent. That's all you do for the percent of increase. Now, let's say that we went from $45 to $35. This would be a decrease. This is the percent of decrease. So you take the original amount, 45, you'd subtract the new amount, which is 35, and you put over the original amount, which again is 45. And then you just solve out this problem. That is all there is to the percent of increase or the percent of decrease or percent of change. So let's take a look at an example here. So the table shows the number of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? Well, on Saturday, we spent 2 hours. And on Sunday, we spent 4.5 hours. So it increased. Therefore, we're going to do the first formula where we're going to take the new amount, which is 4.5. It's really bad. Oops. 4.5. And we're going to subtract the original amount, 2. And we put over the original amount of 2. So we end up getting 2.5 over 2, and we divide it, and we get 1.25, which changes to 125%. So your online time increased 125% from Saturday to Sunday. Okay, it more than doubled, so it went up over 100%. So in this area here on your own, you're going to find the percent of change, and you're going to round to the nearest tenth of a percent if necessary. Okay, and you'll do that at the very end. So again, we're doing since these are both going to be increases, you're going to use the formula new amount minus original amount. And you divide that by the original amount. So why don't you go ahead and give this a try, see how you do, and I'll check in with you in just a moment. All right, let's check in and see how you guys did. So since these are both increases, we're using this formula up above. Let's go ahead and plug in our numbers. So it increased from 10 to 25. So the new amount is 25. The original is 10, so we're going to do 25 minus 10, and we're going to put it over the original amount, which is 10. So 25 minus 10 is 15. So we have 15 over 10. And so we have 1.5, which becomes 150% increase. You do need to state whether it's an increase or decrease, okay? For our next problem. Again, it's another increase problem, so we're going to take 65, the new amount. We're going to subtract the original amount of 57. We're going to put that over 57, because that's the original amount. 65 minus 57 is 8, over to the 57. When we divide, we get approximately 0.1403, kind of rounded there. And so this would be about a 14% increase. Now I made it 14 because if I had the when I did the 0.1403 and I moved the decimal over 2 places, I get 14.03, and that rounds to 14. That's why it's 14% increase, approximately. Okay, here is our next example. It says the bar graph shows a softball player's home run totals. What was the percent of change from 2012, which is right here, to 2013? Well, we went from 28 to 20, which means it decreased, so this is a percent of decrease, so we're going to do the original amount minus the new amount over the original amount. So our original amount in 2012 was 28. We're going to subtract the new amount, 20, and you're going to divide it by 28, the original amount. 28 minus 20 is 8, divided by 28, and we get approximately 0.286. So the number of home runs decreased about 28.6%. Again, we're doing the complete sentences if it's a word problem. If it's just a increase problem or a decrease problem, they just tell you, from this number to that number, like we see in that last examples 1 and 2, or the last 2 problems 1 and 2. You don't have to write a complete sentence. But if it's a word problem like this, please write it in a complete sentence. Okay, our next key idea is percent error. A percent error is the percent that an estimated quantity differs from the actual amount. So when we're trying to make an estimate, once we find out what the actual is, we can find out what our error was from what we thought it would be compared to what it actually is. So to do this, you take the amount of error and divide it by the actual amount. So you're either going to take the new amount and subtract the original if it was an increase, or you take the actual amount and subtract the estimated amount if it was a decrease. You'll see here in a few minutes how we do this, but that's how you do a percent error. You're going to find the amount of error, basically it's the amount of change, over the actual amount. So, for an example, you estimate that the length of your classroom is 16 feet. Okay, so this is your estimate. Your estimate is the classroom is 16 feet. Now, the actual length is 21 feet. So you're off by 5 feet. So what we're going to do is we're going to take our new amount, or I'm sorry, the actual amount, since it's greater. We're going to do 21 minus the estimate since it was the smaller amount. And we get 21 minus 16. We're going to divide that by the actual amount. Remember, we're using this formula right here. So the actual amount is 21. So then it becomes 21 minus 16 is 5 over 21. And 5 divided by 21 is approximately 0.238. And then as a percent, you move the decimal over 2 times to the right, and you get the percent of error is about 23.8%. Okay, so on our first on your own, it says in example 2, which I've gone ahead and put that softball information up for you. What was the percent of change from 2010 to 2011? So go ahead and take a moment to solve this problem. We'll check back in just a sec. All right, let's go ahead and take a look at this problem. You look at the percent of change from 2010 to 2011. So I went from 18 to 10. So this is a percent of decrease, right? So we're going to take the original we're going to subtract the new. We're going to divide that by the original, right? So we're going to have 18 minus 10 over the original, which is 18. So we have 8 divided by 18, which is approximately 0.444. It's 4 repeating. So our answer in this one would be the percent of change is about 44.4% decrease, or is about a, sorry, it's about a 44.4% decrease. All right, so hopefully this was something similar to what you came up with. Let's take a look at our final example, or final, problem here. Number 4. It says, in example 3, which I've placed right up here for you, in example 3, your friend estimates that the length of the classroom is 23 feet. So the estimate is that the length is 23 feet. Who has the greater percent of error? Okay, and explain. So think back to example 3, maybe look back at your notes, see what you did, and then go solve this problem and explain, and we'll get back to you in just a moment. Okay, so being a percent of error, we're going to be doing, I'm going to remind you what this formula looks like. For the percent of error, this is the amount of error divided by the actual amount. So in this problem, we estimated 23 feet, and the actual length is 21 feet. So we're going to do 23 minus 21 over the actual amount, which is 21. We get 2 divided by 21, which is approximately 0.095, which is approximately 9.5%. So the question asks us, who has the greater percent error? Well, your friend your percent of air was about 23%, if you remember. So I'm going to put down your air was approximately 23.8, and this is your friends. So friends air. So the percent of air is about 9.5%. And so then your percent of air is greater. Okay, so hopefully this was an easy section for you. Wish you the best of luck. We will talk to you here in our next lesson. Take care.
Oh, I'm a gummy bear. Yes, I'm a gummy bear. Oh, I'm a yummy, tummy, funny,